If you want to make it more neater, I'll just say concatenate a space and then this one and then go on as long as I want, and this gets a little neater. So that's strings. We've just seen a sneak peek into the data type. There are several other possibilities and functions that we can play around with the string data type. So we've covered 4 important and basic data types. We've covered integers. Sorry, let's start again. We've covered integers. We've covered float. We've covered string, and we've covered boolean. Let's look into a couple of more advanced data types offered by Python. We now need to look into something called list, tuple, set, and dictionary. Now, out of all these 4, we'll be very frequently using the data type list. So like we already learned, list is a collection of homogeneous or heterogeneous objects with Python in any order. So let's say we have 4 different values, let's say numeric values 1, 2, 3, 4, and then we want to sort them into a list. So I'll say list 1 is equal to, now this is a syntax to create a list. We'll actually put the values inside a square bracket. I'll say add a few numeric values like 1, 2, 3, 4, and 5. So these are homogeneous values. If I check the list, I can see that the name list1 comes with the type list. It has a size of 5 elements, and these are the values. I can access each individual element with the appropriate index. So as a list of 1, and I'll take the 0th element. So indexing in Python starts with 0. So let's say if I say list 1 0 index, I'll actually get the value 1. As you see over here, we have the value 1. I can actually make something like something more random. I'll say list of 4, I'll get the 5th value in the index, that is 5. I can actually take a start point and an end point. I'll say everything from 2 to 4. And I'll say that whatever starts at 2, which is 0, 1, 2, the third one, up to the 4th one. And this goes on. We have additional handy ways to navigate through a list. So let's say everything from the second one onwards, from the second index onwards. So I'll get 3, 4, 5. And we have a couple of additional ways to handle them. Now, lists can also be added with new elements. So let's say I have list 2 is equal to 3, 4, 5, 6, 80. And I execute that, so I have list 2. And if I want to create a new list, list 3, which is a combination of list 1 and list 2, that is possible by just this concatenation statement. I'll say list 1 plus list 2. And if I execute this command, I can see the list 3 is a combination of list 1 and list 2 with the size 10. List also provides you additional handy commands. So let's say if I want to check something whether it exists inside a list, or I want to check the length of a list, you can just say list 3 and just say dot. Spider provides you the list of commands that are already available. So let's say I'll say list append, and I'll say append a new value called 98, and I check the value over here. So the value has now updated. So I can just say a list print list 3. You can see that the value has now been appended. I can see the length of a list. Length is a universal command. Length of the list, it's 11. Let's look at a couple of more inbuilt functions available over here. I can say list count, extend, index, pop, reverse, sort, several of them. We look into a couple of more as and when we require a list. But for now, I think this would suffice. Now, this was a homogeneous list where all the elements inside a list were of the same data type. But that's not necessary. You can actually have something like a list of an integer number, a decimal number, a string, and another list probably, let's say 1, 2, 3, 4. And if I execute this, I have a new list, which is a data type list, and has 4 elements. The first element is an integer, the second element is a float, third element is a string, and the fourth element is the list itself. Now I can create a list of nested lists in itself. We'll get at the complexities and what all other formats exist, and probably what other operations we can do as and when required. Let's move on to the next data type, which is tuple. Now, the difference between list and tuple is very straightforward. The primary difference is tuples will actually be loaded into the memory once and can never change it. So with list, in this scenario, let's say we want to access list new and the third index, which is the fourth element. So I'll get the value, which is again a list 1, 2, 3, 4, 5. Now what if I wanted to update it? I could say the access that appropriate number, and I'll say I'll update it the new value, which is a string value. Now it gets updated, and if I check or print the list, I can see that the list is now updated with the new value. You see this? We have the new updated value over here. But there are scenarios where, let's say, if you assign a value to a list, you would probably want that to remain same throughout the program's execution. Or probably you would have strict rules that these values should not change or they should be immutable. That's when we have a tuple. So let's say we have this list new, which is the new list which is created after modifying this value. These values should be the final ones, and no one should be given the permission to alter these values. That's when we can use the data type tuple. Once a value is stored inside a tuple, we cannot change it. So for example, we create a new tuple, let's say tuple1 is equal to tuple of an existing list. Let's say we create it out of list new. So now this would be a tuple. Now if you come over here, tuple1, the type would be tuple, size would be 4. And the good part of this would be it's immutable. Now we can access the elements of a tuple similar to what we have done for the list. So I'm saying tuple of 1, 1 would be the second element of the list. We can actually access that value. But then if I want to change it, let's say I want to change it to a new value, I would say update it to 100. Now if I try executing this command, you can see that we get an error message saying that tuple object does not support item assignment, which means we cannot change the value during the course of the program execution. So that's the difference between a list and a tuple. We have one more data type which is almost similar to a list, and we call it a set. Now this is similar to the set theory which we have learned during our college days in mathematics. We create a set of objects where duplicacy is an issue. So you cannot have duplicate elements inside a set. So let's say we create a set from a new list. I'll say set1 is equal to set of list underscore new. It's the same process, and you can see that we have a new data type over here. I think we execute this. Let's say we print this. We have the values over here. String 1 and new value. You can definitely change the values of the set elements. The only difference is you cannot add duplicate values. But in case if you add duplicate values, it won't throw you an error, but it will just remove duplicate values. So for example, let's say we have a set called set new, and we're creating a set of a list of 4 elements. Let's say 1, 2, 3, and 4. Now this would be a perfectly valid set. We'll have the values over here. My apologies. We made a small syntax error over here. Yeah. This will be a perfectly valid set. If I execute this set new, you can see that there are 4 values over here. But let's say if we add duplicates over here, we add 4, 4, 4, and 4. So we have 5 instances of the value 4. Now if I execute this command or code, it won't actually throw an error. It's just that it will remove the duplicates, and if you check the values in set new, there'll still be just 4 elements. If we add a couple of more, let's say we add something new, 555, that new values will be incorporated over here, and you can see that the values are non-duplicated ones. So we use a set when we are least bothered about uh, having duplicate values. It's just that we just don't care about duplicate. We just need unique values, and we don't want to actually take care of ensuring that every time an element is added into the list, there are no duplicate values. So in that scenario, set would be an idle thing. Now, like uh, indexing in list and tuples, indexing is not supported in the set data type. The last part, or the last data type which we would like to cover in this section, would be a dictionary. So dictionary is a scenario where we want to access values with a key value combination. So let's say we have something called dict1, and we're creating a new dictionary with, for dictionaries, we create dictionary1 is equal to curly braces, and then we put in an index a with some value. It could be, let's say, 1 to 3. Then we'll have another value separated by a comma, let's say b, and we have the value some string, let's say the. This is a dictionary of 2 elements. Now, if you look over here, we have the dictionary 1 created with type dict, and it has size 2, and it has 2 elements, 123 and the. But the way you access the dictionary would be with the index you have created for that particular value. So if you want to access 123, the index corresponding to 123 is A. That is, it's a key and value pair combination. So if you have it A as the index, we can actually access the value. We've not A. Oh, sorry. There you go. You can see the value 123 being accessed. You can then access the remaining values. Let's see, access with B. You can access the. So you can actually have homogeneous as well as heterogeneous values inside a dictionary, and you can append the values to a dictionary, you can add more values to a dictionary. It's just like the same stuff. So let's say I will say dict1, and I'll say a new value t is equal to 100. And if I execute this, I'll have the values updated with the third key value pair. So whenever you want to access any data type or any data values with a key value pair combination, dictionaries are the ideal ones. This comes in handy specifically when you're handling JSON files. We have specific use cases where dictionaries are extremely useful. We'll have all of this in practice in the upcoming sessions when we get hands-on with data engineering. That's the time when we'll have majority of the codes and majority of the functionalities of these 4 different data types exploited to a different level. But for now, just for the basics, I just wanted to showcase the 4 important data types, basic ones like Boolean, integer, float, and string, and the more advanced ones like list, tuple, set, and dictionary. Next, we'll actually look into something more advanced within Python. That would be NumPy and Pandas. NumPy and Pandas provide us an easy way to handle array operations and data frame operations. We'll get into the details, but let's get back to the slide.